Now we will draw the block diagram. So block diagram of a feedback control. Block diagram of a feedback control system and its transfer function and its transfer function. So I showed you different blocks. So this is my comparator block. So I call this signal as RS, that is the Laplace transform of RT. This is my set input. Then in the feed forward path, I have the first element whose mathematical model I can call it as G1s. So this I will call it as G1s. Then I have another mathematical model, that is G2s. Now I have the plant which I am going to control, and this is the system or plant. So this is the output of the plant. I call it as CS. So this I will note it as plus minus, that is my negative feedback. And here I have another block which I can call it as HS. That is the mathematical model of my feedback path. So this is my feedback. So RS, CS, this is called ES, error signal. This is called a BS, feedback signal. So I am going to call this as G1s, that is the transfer function of your amplifier. G2s, G3s, that is a plant. So this block I can call it as HS, transfer function of my feedback path. But these are transfer function model. But G1s is a transfer function of your amplifier, G2s is a transfer function of your actuating block, transfer function of your plant. So this is our feed forward path and this is my feedback loop, feedback path. So this is feedback path. So I can call G1s, G2s, G3s as GS. So this I can replace it by a simpler block, RS. So this is BS plus minus, that is negative feedback. Then I am going to call this block as GS, that is the transfer function of my feed forward path, feed forward path, yes. Then I have my feedback path. So this is CS. So I will call this block as GS. This is HS. So this is ES. ES, error signal. Appo RS is reference input. Reference input. S domain lana nammal cheyirikkunna reference input. CS, controlled output. Controlled output. Appo enikku adana control cheyendathu plant. So that is my controlled output. BS, feedback signal. Feedback signal. ES is error signal. Laplace transform the error signal. So that is my error signal in S domain. Error signal. GS, GS, which is equal to G1s, G2s, G3s. So this is transfer function of the feed forward path. Transfer function of the feed forward path. HS, transfer function of the feedback path. Transfer function of the feedback path. My ES is equal to RS minus BS. Negative feedback aanu. RS minus BS. BS equal to CS into HS. CS into HS. CS is equal to ES into GS. So I can substitute all these things. So CS is equal to substituting CS is equal to ES, that is RS minus BS. CS is ES into GS. So that is equal to RS into GS minus BS into GS. Now I can substitute for BS. So RS into GS minus BS, CS into HS into GS. Now I can bring this side. So CS plus CS GS HS is equal to RS into GS. So CS into 1 plus GS HS equal to RS into GS. Therefore, transfer function, overall transfer function. Therefore, transfer function of a standard, standard block diagram, transfer function of a standard closed loop control system. So that is CS by RS. CS by RS equals CS by RS is GS by 1 plus GSHS. ഇതാണ് ഒരു സ്റ്റാൻഡേർഡ് കൺട്രോൾ സിസ്റ്റത്തിൻ്റെ ട്രാൻസ്ഫർ ഫംഗ്ഷൻ GS by 1 plus GSHS. ഇത് പോസിറ്റീവ് ഫീഡ്ബാക്ക് ആണെങ്കിൽ പ്ലസ് വിൽ ബിക്കം മൈനസ്. അപ്പോൾ GS by 1 minus GSHS for positive feedback and GS by 1 plus GSHS for negative feedback. So this is important. So CS by RS equal to GS by 1 plus minus GSHS plus for negative feedback, plus for negative feedback and minus for positive feedback. So this equation is very important. GS by 1 plus minus GSHS, plus for negative feedback, minus for positive feedback. Where GS is transfer function of the feed forward path. Transfer function of the feed forward path. GSHS is called loop transfer function. Loop transfer function or open loop transfer function. Open loop transfer function. GS by 1 plus minus GSHS, that is closed loop transfer function. Closed loop transfer function. Above feed forward transfer function, loop transfer function or open loop transfer function, closed loop transfer function. Closed loop transfer function. 1 plus GSHS, negative feedback, 1 plus GSHS equal to 0. So this is called characteristic equation. Characteristic equation. For 1 plus GS is equal to 0, characteristic equation. GS by 1 plus GSH is closed loop transfer function. GSHS is loop transfer function or open loop transfer function. GS is transfer function on the feed forward path. But GSHS is employed. So you have to note down GSHS is employed for analysis using Bode plot, root locus, Nyquist plot or polar plot, etc. 1 plus GS is equal to 0. 1 plus GSHS is equal to 0 is used in Roos stability criterion. For Roos stability criterion evaluate we have to make use of not GSHS, 1 plus GSH is equal to 0. Roos stability criterion. അപ്പോൾ സാധാരണ നമ്മളൊരു കൺട്രോൾ സിസ്റ്റം അനലൈസ് ചെയ്യുമ്പോൾ നമുക്ക് ഓപ്പൺ ലൂപ്പ് ട്രാൻസ്ഫർ ഫംഗ്ഷനാണ് വേണ്ടത്. പക്ഷേ റൂസ് സ്റ്റെബിലിറ്റി ക്രൈറ്റീരിയൻ ചെയ്യണമെങ്കിൽ നമുക്ക് 1 പ്ലസ് GSH is equal to 0. ബാക്കി എല്ലായിടവും I require GSHS. So this is my basics of control system, first part of your basics. So later on we will study the transfer function derivations of various control system elements, then steady state analysis, transient analysis, etc. That is the first part of your control system. Then block diagram reduction technique, signal flow graph, Mason's gain formula, these are employed for finding the steady state and transient analysis. Then in the second part we will use the stability analysis. I will be employing Bode plot, root locus technique, polar plot, etc. for finding the stability values, both information regarding absolute stability and relative stability, etc. And once I know the stability analysis, I will come to know what is the amount of instability and what type of compensator is required. So I will be doing what is PI control, PD control and PID control. So that is my that is my briefly we are going to do the state space approach. So this is all about your first part of your control system. So we will stop today.